Hi, I'm Jacob Dahl.
I'm Justin Wonlett.
And then there's the cameraman's Gavin. We worked on a start-finish timer, and the purpose was to make a racetrack that would time a runner with the bump switch, and then the ultrasonic timer would eventually trigger the finish line, and then there would be a red light during the race. I can show that again. And then once it crosses the finish line, a green light flashes twice. There's also a timer that shows the timer variable on the actual program. So that was 1 second. So the SATO code is just push bump button, red light turns on, clear and start timer, and then it keeps going until the ultrasonic reaches 42 millimeters. And then the set variable for the timer equal to 1 to T1, which is the timer. So it says a variable that equals to the timer. And then the red light turns off once the ultrasonic is triggered, and then the green light turns on, waits, and then turns off, turns on for 0.5 seconds, and then turns off for a couple times, and then the program's done.
Hi, I'm Nathan Stang.
And I'm Matthew Maher.
And I'm Matthew Flora.
And this is our elevator.
We had to create an elevator that could go to any floor in any combination of ways. We used 3 push-button switches, and there's an LED that corresponds with each floor as the elevator is on said floor. And we will show you an example.
We also had to develop a safety precaution that every time it is left for 20 seconds, it needs to return to floor 1. So let's show them that. We need some Jeopardy music here.
Do 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 do. Do 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 do. Do 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 do.
Woo!
What? Well,
Is the voice activated?
no, it's waiting.
Oh wait, it has cameras.
Nope. Those are sensors. It's supposed to stop on a green line.
Wait a second. Oh, no. So did you have to program at least this?
Yeah.
So this is our car that we've built for Principles of Engineering. It is a fully autonomous car that will drive itself wherever it needs. Here on the car, it has 4 motors that spin each of the wheels. It has a cortex that controls everything. Everything is plugged in here. There's the sonars, which send out sound, deflect, and return the sound, giving us a distance as to how far. We have 4 of them. And on the underside, we have a line sensor that will detect the reflection of the line and send it back. That's good. Do we need to turn it on?
Demonstrate.
So our car is looking for a color to stop on, but due to this floor there is no color, so we'll just keep looking.
Hi, I'm Eric Molly. This is my robotic arm for Principles of Engineering class. So I had to make a robotic arm that was able to move in 3 places and be able to pick something up. So this is what I made. Works reasonably well. To control it, I'm using these things called potentiometers. They measure how far something's twisting. So I have it set, if it's under a certain value left, it rotates to the left. If it's a certain way to the right, it'll go right. And so on, same with the claw. And the up and down. Other than that, that's about it.